Voice bad, by the way, because
No.
my nose is a bit.
It's
Uh,
definitely not as bad as mine.
yeah,
You're.
that's
I mean,
fine.
you're not bad, but you are very. Yeah.
Okay, we are recording though. You can continue talking about it.
Okay, so we were talking about what to do as with the runtime of the language and what are the next tasks and etc. Right.
Yeah.
So when Claude envisioned the relational model, he was thinking ahead and not only about the model. So he first thought of the design principles. So that is the RM, right? The relational model, which is a way to model uh, objects of the real world with relations. So you're basically using set constructs to define the tuples. It's like the thing I showed you guys last week, I think.
Yeah, yeah.
It's the
Relational algebra.
it's a way to yeah, it's a I mean, it's bringing set theory. I was more concerned with set theory than relational algebra on that, but I think both are intertwined, right? So a relation is basically a descriptive way to abstract a set, right?
Uh-huh.
Uh, a relation is basically a set with a rule. Uh, so loosely speaking, so the idea here would be that the original intent was to embed the relational model with its language in another language. So Datomic does that correctly, funny enough. So you have data log, and data log is embedded inside of Clojure,
Yeah.
right? So it feels very natural to just go from one to the other.
Yeah.
And that's the
And that's
idea
a
of,
similar effect that we want to achieve here.
yeah. So in this case, we have a even higher benefit than Clojure because we can just use the plain language, right, to do that. We just need to change the runtime. So not even the syntax would change, I
No,
think.
no, no, wait. But that's exactly the point I want to talk about because I think we have a couple of options. Let me share my Emacs. So you asked what is the dream. So let me tell you what is mine first.
Okay.
So my dream for this thing to do its thing would be something like this. So let me actually send you guys there and make this full screen and increase this. Am I using the correct mode for text?
Let me see. Just give me a moment.
You are 5 FPS.
For text. No, I don't know if that's the correct.
It is. For text, it just gives you 5 FPS and it's really, really sharp.
Okay. So
Yeah,
my
it is.
dream would be like at least now. I'm open for better alternatives. Okay. I I would like for it to be the most transparent as possible. So when I'm reading Clojure and Datalog, when I look at the code, although it's embedded, I can immediately notice it because it has unusual syntactical elements. In
Oh, it is
here,
made up of a function call with the another language embedded inside of it, right? So
no, yeah,
that
it
that's
has
already
Clojure
different.
data structures to materialize the data log stuff, but I would like the database stuff to look like Prolog, to look like this.
Yes,
You
this
would
is
not
what I
be able
meant.
to differentiate just by looking at it. So I would just do this, and then the code
And then the next expression.
from this point onwards, the code could be exactly the same, but it would mean something different. And what I mean by that?
It's very ambitious.
No, it's no. I'm gonna go even crazier, which is from this hypothesis we can diverge in two ways. The first way is that the code generator takes notice of this flag and it generates different code for this. And when I say different code, I'm specifically talking about these instructions here. So these are all the instructions of the book reference book. I
Mhm.
want to go even further, which is the instructions are the same that's going to be generated out of this shit. But the evaluator, which is the last step of the entire pipeline, this guy it will take notice on the flag, and it will
So
evolve the instructions differently.
okay, let me interject for a second. So there are multiple ways to. I'll pick like a normal database vendors. So for example, Postgres doesn't compile the commands to a sublanguage. It just, I mean, it does, but it's not important. What it does is basically build a tree out of this. So let's try to build a query out of this factorial thing. How would that look like if you were building a relation, right? So it would be uh, multiply. So multiply is a function call. Negate is also another. So it's basically function calls with a search on
Recursion.
factorial itself, right?
Yeah.
So how would that look like if you have a table? So this is an infinite relation that would have cardinality LF0 that looks at the uh, number n, and it's just two columns with a mapping of number of a number n and the outputs that are calculated with a join on the multiply, negate, and plus. I think I would see it that way. And those could be primitives, right? Multiply,
They are.
plus,
Currently,
negate.
they are already.
Yeah, those I think although we could handle them as sets as well, I think that would be too silly and probably inefficient. Uh, but okay, so let's assume they're primitives. So you could calculate those two by just aggregating them, right, and making the joint state with all of them. So for example, why do you have the minus there with
Oh,
one?
it's because. Well, let me explain this
Oh, I
first.
see. Because you're picking the previous.
Yeah.
I see. See. So you're doing. I see. So
I don't
by
remember if we did this just to exercise the new instruction or if it's because we don't have syntax for
the
negative
minus,
numbers.
right?
No, no, it's because of the former. It's because I want to. I think there is an example somewhere that we. Yeah, we do have negative numbers. This is not like we weren't that silly, Marinho. But I wanted to exercise all the built-ins in a single program.
That's good. Okay, so that's just a minus one, right? So and then you would have minus one with the previous, and the previous is the what you keep going on the recursion of the factorial. That's pretty good. Okay.
Yeah.
So yes, this is one example that I think it should be possible with the things I was doing. The problem with this is how to convert the language, and then Postgres generates a AST. So when you do a query, you do like select blah blah, and then you do an order by, and then you do like a limit. So those commands, those specific commands, they are gonna be converted in a specific way depending on flags and a bunch of other heuristics that Postgres can infer, right? So it breaks down in a tree and tries to execute the nodes from the leaves all the way to the top, and that's the result. And then it just gives you an iterator, and then you just iterate over the set. That's the idea. Is that clear or
No, I think that's
confusing?
clear, but I think that's going a little bit too.
No,
What
no,
can I
but
say?
wait. I'm
Go,
not done yet.
go for it.
And I'm just saying this for a contrast because what I think makes most sense in our case is to use what SQLite does. And can you go to the instructions?
Yeah.
SQLite outputs instructions like these.
No, 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 but that's
You see?
exactly no, no. But again, I'm gonna reiterate my dream. My dream is, which I have absolutely no idea if it's even feasible, is that the code is the same and the instructions are the same.
Yes, yes, I'm telling exactly that. The code is the same, the instructions are the same, they're just interpreted by different
Yeah, but there
runtimes.
is a okay. There are a couple of questions with that theory, which is first of all, which is what Marinho brought up before you joined. If we generate the code for this using the prolog semantics, do we have enough information to talk to the relational engine?
I think so. I mean,
I have no
supposing
idea
that
at
you
all.
would start the thing with a like for example, you would need obviously to have This way, you're defining a relation factorial, right? In this case, it is an infinite relation. So you would need to type some stuff there. So it's not like a free lunch, right? So you would
No, no,
need
no.
to
Yeah,
tell
I think that's your
the
job.
thing that
How it's gonna a query is gonna look like for the factorial table. That's up to you, Magit.
no, what I'm saying is like you need to put the sets that you are operating in, right? And
Oh, you
in
mean
this case,
typing
you're just
this?
operating with numbers. Yes. Why? Why?
Well,
Because
because that's first normal form. Like you need to define the
uh,
types of the thing.
well, yes, but not really the what I meant. So here's the problem. What is n? Like think about the nature of factorial. That is a relation that is infinite, right? You can have infinite, like you give me any number in the naturals and it can produce the factorial out of that natural number, correct?
Mhm.
Yep.
So the nature of functions that operates on these sets is equals to the cardinality of the set.
Mhm. Mhm.
So in this case, you would have integers, so z, right, the set of
Oh, that's
integers.
fancy. I don't have
Yeah,
the Unicode.
you don't have the fancy z. Okay, so you would have z. So z is the set of negative and positive numbers, like natural numbers plus the negative counterparts, right? Plus zero.
Mhm.
Uh, so it's infinite. Cool. So can you define that?
Well, that's actually a good point. We don't have support for. Let me put it like this. Right now, the way that the code works, we have nothing outside of the scope of Prolog. So, for example,
So
typing this shit, we don't have it. We have to make it.
yes, exactly. So the problem here would be that on the it's think of a database. You would need to have the z relation, right? A set with z. It's a type.
Okay, so you're
So
telling
you would
me
need
that
to
the first step to this magical goal is to add a type checking.
Not
not
quite.
really. Let me
Lemos,
make
remember
it clear.
remember the net. Remember when we defined net, Lemos? We need something like that, basically.
Wait, define it what?
Let me share my Emacs and see if it makes sense.
Manny, could you repeat?
Net, net. Remember when we defined the natural number for type checking?
The natural number for the type check. Where? Which context are you talking about?
Before we had integer literals, when we were doing piano numbers.
Ah, I remember.
Yes,
I remember that.
that's one option. So here,
Let me
oops,
put your screen on top of mine, yeah.
don't know if I need to increase. Is that
But how
okay?
is this not type checking? Anyway.
Uh, well, it's let me finish explaining, and then you see the similarities and the differences. I
Okay.
think it's easier. So, because you're not gonna, I mean, we will need to type check as well, but it's not just a compiler executable thing. It's at the runtime that we need to generate the values that are demanded because we're dealing with infinite, so we need to be lazy with them, and
Mm-hmm.
that's the silly
Mm-hmm.
part. So, for example, here, so what is the set of z? Well, it's gonna start in the minus infinity. Then we're gonna have one guy here. Then I don't know. I'm gonna start on minus one, then zero, then one,
Um,
then two.
Actually, it's more principle to start with simpler integers and move to more complex ones, and that would make us
Let's.
start at 0 and go to 1 and minus 1, then 2 and minus
Yeah, I
2, and
agree. I agree with Marinho that we should start. Yeah, let's exactly.
That's easier. I
Yeah.
guess that's easier to see, right? So you only have one way to go to off bounds. So it's unbounded up, right? So
Mm-hmm.
it's going to infinity on the positive side. And depending on how you define naturals, maybe you don't want zero, but whatever. I'm gonna keep it. So what's the cardinality of that?
Isn't it the thing that you talked about last week that I keep forgetting the name?
Yeah, LF0. That's it. So you need this to be able to tell. So this is the thing you need to be able to tell how much this relation can end. So if you notice it's LF0, So you need to define it, right? You
Mm-hmm.
every operation you use with this, you need to take because it's gonna be lazy, right? So as many, it's a generator. You can only use so many as you can process. So you can't just process ad infinitum.
I see.
So that's not how it works. But okay, now think about this. So when you are operating a function over it, let me pick a simpler one. So f of x is equals f of x plus 1. So this function is basically successors of x, right?
Mm-hmm.
How does this relation look like? Remember, functions are relations. So
Mm-hmm.
input, output.
Yes.
This looks like this: 0,
One.
1. Oops. 1, 2, 3, 4. Oops, I skipped 2. 3. Ah.
Uh-huh.
So 3, 4. And so on, right? So it is also infinite, this trash here,
True.
right?
Mm-hmm.
And I'll even type here, so net. So x is net, therefore this thing will never end. So how would you produce this? Well, you have a rule and you have a set that is infinite. And you apply that rule for every element of the set in a particular way. That's basically it, in a naive way.
Okay, so we need to set check the inputs. Is that what you're talking about?
Basically, because you can't just define these without having like, okay, what is this? I have no idea. Like, what is x? Right? Where do I take this relation? Where do I take the values of x from? Remember, we're doing relational algebra, right? So this would be like a join on the naturals. So where the heck do I pick the elements for substituting x here? So x would be an element from naturals. Okay, so then join this rule with the naturals, and then that means for every natural, produce the successor, add 1. And then it just goes ad infinitum. You
Yeah,
see?
no, this makes sense to me, but I'm having a hard time understanding what problems that causes in our implementation. I guess that's what I want to say.
Because right now, uh, did, did Marinho say anything, or
No, no, no.
is it just.
Go for it.
Okay. Uh, So the problem that I see right now is that we cannot distinguish what are the elements. I mean, they could be just labels. But for example, when you say n there,
Uh
where
huh.
the heck does n come from? I don't know.
No, that's within. Like I told you, this is prologue. In prologue, that question doesn't make sense, right?
Yes, I know. That's what I'm saying. We would need to extend the language to add uh, a label that for the language itself may not make sense, right? It's probably just a thing. And to be able to have primitive relations, like for example naturals, which we already have integers, right? So they
Yes.
could be already a set. So we would have on the relational engine some infinite sets, like the sets of uh, numbers, for example, of rationals for countable sets, right? Yes, something like one thing here, Lemos, is the following: you would only need to type the n, right?
Oh,
Because all the
that's
others are
awesome.
produced.
Okay.
You get that. Not even
Oh,
the out, I think.
no, only the in you said. Okay.
Yes, because it's only the value that you need to use to generate a element, right? So that's the only input
Mm.
that you have for factorial. It's the natural.
Mm. That's actually a pretty interesting point because I always seen
Uh,
until this point that
actually,
everything are inputs. That was my interpretation before.
Um,
actually,
they are,
Lemon,
but they are
we
out
should
of
be doing this.
products of the.
We
Go
should be
on,
doing
Maria.
this exercise on the Factorial Online 1 because this is the implementation detail, right? This is doing a tail recursive using the accumulator.
No, but that's the thing, Marinho. The factorial here is a prolog factorial. The factorial here is a factorial table because this is the syntactical element.
Then in
Don't
that
say
case,
table,
there's
please.
Why would a table of factorials have accumulators?
Exactly.
So we would teach this. I
Well,
like
we
it.
need to rework on the rule, right? How to generate it.
No, but that doesn't matter to this point. We are on dreamland. Let's imagine, let's simplify all the complications and let's just try
Oh,
to dream a little
copy the
bit.
one Marinho sent. That's a good one.
Okay,
It's the exactly what I did here.
that's not. Okay,
So in
all
that
right.
way, you don't need to put the label, right? So net is assuming that it's already a relation defined in the primitives, right?
Uh huh.
Yes.
So that's perfect. That's it. So picking every element. So the or, sorry, not the or, the end there. The by the way, funny enough, you know that on the from in SQL, on the from, if you put the comma on two tables, it does the cross product.
I didn't know that.
It, now you do. And why? Right? Because that's exactly the what we are doing here. We're generating the projecting one set on the other, onto the other.
Yeah, no.
This is slightly different. This is not a cross product, right? It's just picking from one
But
guy and
this
applying.
what Marinho wrote. This is the f function that would define the f of x that you have in your Emacs, right? This is the f of x
Yes.
in your Emacs.
So that would be using my same terms. It would be value input and output, and then it would apply 0, and then the out is 1, right? And then
Exactly.
net just recurse over.
Okay, but I want to talk about. Okay, let's suppose that we have a table in the disk that the relational engine is reading for us that has two columns. An input. Let's say actually let's go even better. It's a caching mechanism. I'm using Postgres to cache factorial. Fuck me. Okay, so I am
Okay.
caching in a
By the way,
particular input.
this is not written in the disk. By the way, and
Wait.
just important to point out because it's infinite, right? So you can't.
No. But in this
You,
particular example, I'm saying that I have cached, I don't know, a million factorial
Okay,
calculations.
you memoized something like
Exactly.
this.
I'm doing memorization with Postgres. I don't know why I would do that, but I am.
Yeah. Okay.
And then I have two columns in there. I have the input and I have the output. How would that look like here if I want to query that?
well, you would first try to run through the cache, and if you don't find what you want based on your inputs, you would have to run the factorial rule, right?
I don't follow. I am trying to do a lookup on the disk, right? The relational engine will do the hard stuff for me. So I don't need to care about file descriptors
You
and
do have
trees.
to, well, if you're doing a lookup on a disk, then either you have, okay, can I assume you have one of the values, either the input or the output?
I have the input.
You have the input, okay. That's just a table lookup. You check, okay, have I memoized the input, whatever I have, and if so, give me the output.
Yeah, but how does that question looks like in this dialect?
Exactly as it is written.
Okay, so to me it doesn't
Because
make
why?
this
Because
portion doesn't make sense.
wait. Why? And I saying this because every tuple is unique by definition, right? It's a
Mhm.
relation. You
Mhm.
can't have duplicates like in a
Mhm.
table.
Mhm.
So you're gonna only have one entry where the in and out are unique, not independently. They can repeat. Like for example, you can have. I mean, this in this relation itself, it makes little sense, right? And that could be an optimization that we can do. But for example, you can have one true and one three, right? In this case, you can't. You can only have one true, right?
Mhm. Mhm.
Uh, and then we could probably like add something like an index for that, but ignore that for now. So you would have one true, one three, one four, blah blah, whatever. So as long as you have a set of one x registered on the disk, let's say, then on retrieval, you could search on a tree, whatever, retrieve the values based on the in already, and then you don't even need to evaluate. You see, it's already memoized, cached, or whatever you want to use it. So it searches by the index, essentially, by the elements uh, in the tuple. So that would switch the evaluation logic. It doesn't need to run the relation to know the answer. It already has the answer, you see.
I think I'm not getting my point across. What you said is all true, but I'm asking something different. I'm trying to ask
Okay.
the question. I know because let's think about all the operations that we have in our competitors. We have create table, we have select,
Our competitors.
delete,
That's how you
of
put
course.
this. I don't think we're even on that level. Okay.
We have update. I am talking about this guy, right? So I'm not creating a relation. I'm not
Mhm.
deleting a relation or updating a relation. I'm just trying to search something in there. And right now, what my understanding is that what I'm asking is how does that gonna look like in our language? How are we gonna do the counterpart of select in our stuff using
Well, the
Prolog
same
as
Well,
the
way as line
base?
25.
yeah, the
It's
same way as line 25.
okay. So this is gonna be like this. Oops.
Yes, with database, right? Yeah.
Okay. Okay. So let me
We can
put
do
this
that
here.
right now, by the way. Right now, we can do that.
Okay. So let's now go to let's go what I think you were talking about, Magneto, which is this.
Yes.
So you
So,
this
first
would
of
be
all, for you
this.
to be able to do the factorial, you need to run that first, right? So, you need to define the thing as something.
Yes. 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 This needs to exist.
Man, don't use the factorial. Use the one, the in out, the 19. That's much easier to
Okay.
read.
So there. And then to define this, you need to say where this guy is coming from, or not.
Yes, which is already the case, right? Marinho defined on the net there.
Oh, so in this case, you don't have to do these
Yeah, I was
shenanigans.
thinking of another syntax, but Marinho is handling the net in a much more seamless way that I think is more appropriate. What I was saying is you could type the sets, so you don't need to. You could type the input sets, so you don't need to type the relation that you are picking things from. But that
Oh,
way, it's much clearer what you want to do.
okay. So you're
Because
saying that
yeah,
yeah, you're saying that these looks more like Prolog to do the type prop to do the set check
not
in
not only
comparison to
looks
this
like
down
more
here.
like prolog, but it's smarter in the sense that it is because why the other syntax is weird is you see that it's just typing the n. Why not the out? That's not like typing, right? But that is not about typing. It's just to give inputs of the relations that you're gonna use on that variable. So it's like a format to introduce something.
Okay.
If you change the syntax, maybe that's less bad. But well,
Well, I was kind of thinking of doing it like this.
I was thinking of doing something. Okay, that
That's
works too, but that's worse. I
I
think.
don't like that. Yeah.
I think that just gets worse.
I
Yeah.
don't
Okay.
like that because then it's not clear if you are matching the input or if you are actually typing it, right?
Okay,
It's
that's fair.
syntactically ambiguous.
That's really
That's
fair.
valid. Yes.
Okay, so okay, let me see if I understand. If you do this after this, then this means that you are creating something in some format, which I have absolutely no idea how it's going to be, but it's going to be written somewhere in the disk in some format that there is a relation called f, right? It has
Mhm.
two fields in there,
Yeah.
and it to know the field, to know the type of the quote unquote virtual columns, you look at this thing. And I have a question. How do you know the set that this is?
Well, theoretically, every relation is already typed, so we can just infer from the body, no?
Yeah. I
But
think so.
that means type inference, and that's hard.
Uh,
But we have Prolog to do the type inference.
yeah, that would be easier. Yes, but I don't think it's a problem, Lemus, because first of all, you don't need to type anything there. Like you can leave the things as dynamic as they are right now. Like
You could also just remove the net in this case, and it will make f work for all integers. But just for the sake of being accurate to Mageta's example, I put the net there to restrict the domain.
No, no. I think the net was a great idea. I think this is the way we should go.
I think so too.
Okay, so
But to be completely correct, you should also put the out with net, right? That's the
okay,
so
so
net
net
out.
out. Okay, and then I have a
So it's
question.
a bidirectional naturals
Yeah.
essentially.
Okay, but then we need to encode this. This needs to be also written somewhere, I believe.
It would
Yes,
probably be a
and I
primitive.
Yes,
the
it would probably be a
plus could be,
primitive.
but you can assume you can have generic rules. We can. So I already did some sketch to write infinite relations. It works, so we could put this there already. So I could. It's just, but you have to write C. That's it. That's the thing.
That's
So if you write like the plus function in C, this works. So you would need to just pick an
okay.
input,
I have
add one
a
output.
question from Marinho now. Marinho, looking at these things and remembering the very little uh, that I remember about the generated code that we keep looking at when debugging this thing, I believe we have enough information. We can do what I said. Would you agree?
Can we? Can we?
Yeah, all of these pieces are available in the generated code. We have this name in the functor table. We have these things. The problem is that these are registers. Those are not names. So that's a minor problem. And we do have this encoded as well, and the names of the built-ins. So I have a suspicion that the current generated code is enough with minor adjustment for the names um, that we can pull this off. What do you say?
Can you save this in a file, in a separate file, Lemus? Call it
Sure.
like integration. I don't know. Infinite relation. Something like that.
Database.
Yeah, that works.
So what would
Just
you
put the
say?
F.
What would you say, Marinho?
Mm,
Actually, I'm gonna keep that.
I would ask you to delete the others. Remove this create table again as well, please.
You will remember what these things mean? Okay.
Yeah. Uh, Put another database, by the way.
Oh, okay. So you want
Let's put this before everything. I think it's easier.
okay. Yeah, I would not. I was thinking more like which language does this type of shit? I think none. I don't know any language
Cobol.
that. Okay, COBOL does
You
that.
would
Okay, so
separate you separating headers, you mean? Like that's literally
yeah,
let's
any 80s language.
assembly as well.
You're comparing your language to assembly, man. You're crazy.
Go, Marie.
let's do it like Perl, okay? If we have an at sign prefix in the name of a definition, that's a definition that goes to the database, and if
Ah.
we
Okay, so you're talking about doing like this.
yeah, and to call yeah like that.
Magetta, you were the
Okay,
judge.
that no, I'm fine with that. Yes.
And then the only question is, okay, do we have to do that for every relation that we put in the body of f as well? Because that would be
I don't think so. I think it's just F, right? Unless we want to mix things, but then I don't even know how to do that myself.
Wait
So
a moment though. What that question is interesting because to me, these examples, for example, all of these things, net, and plus, they are built-ins. They are not other relations
no
in
no
this
no no
case,
no
right?
no Lemos. They are built-ins, but in this case they will be built-ins of the database, not of the
yes,
Yes,
language.
yes, I agree. I
they're
agree.
they're built in, but and one thing, they're built in of the database relations. So there are relations on the database as well.
Yes. But what I think Marinho is talking about is something more like G, I don't know, whatever, and then we have
The
G here.
That's cursed.
Yeah, you should be able to do that, and you wouldn't need to use the at sign. But the point is, you wouldn't be able to just call. You wouldn't be able to call Prolog code from the relations
Yes,
defined in the database.
mixing the runtimes, I think, is a
Yeah.
recipe for insanity.
So
I
this
don't think
needs
we
a
should do that.
at. So this needs an at.
Yes,
Yeah.
yes, because you're defining G, right, as a fact.
Okay, so the first rule, we don't have comments, so bear with me. First rule, no mixing of runtimes. Prolog is prolog, db is db. So we cannot, we need to do this check. When doing this thing, we
I
need to
mean,
check if we are either a primitive of the database relation or if you are
it will
a
just
relation
look
that lives in
right.
the database.
Yes, the first thing that the runtime does is check existence of those objects, right? If it's not there, the at sign is just to know that it's a database directive, Anata. So
Yeah,
it
so
it
we can
redirects the runtime,
exactly we can switch the runtime mode.
and it's a good symbol.
Yeah. Okay. So what other rules?
Unless we want to use like some Greek letter,
Uh,
like
here.
delta,
No, no, no,
but
no,
then you
no.
need a keyboard with
Yeah,
delta
let's
to
not do that.
program.
I hate that. Okay, so true.
APL
You
people will be happy.
you are either um, database
But it wouldn't
database
runtimes be together?
built-in. You mean this
I think so, right? It's the
or
same way.
Yeah.
another DB relation? Okay. What
Yeah.
else?
Well,
I
you
think
will need to
Prolog.
define what A is as well, right?
Yeah.
Sorry, repeat.
And
You need to define what A is as well.
Oh, okay. So in this case, net A.
Yeah, but that's kind of
Um,
redundant, right? Can you add
inputs. Uh,
let's think. You guys don't have lists, right?
we're gonna
So
implement those today if we have time.
do you have equality? No, you don't have equality. Can you
We
put
don't
we
we
like
don't
do
have
we
one?
equality because we have unification. What are you talking about?
Can you put one in the A instead?
Of course.
I
So
mean
then
we
you
can
can only
implement
have.
we can implement equality, Mageta, like this. It doesn't have to be a primitive, oddly enough.
We can. Well, yeah.
I think
Actually, Marinho already wants to have a standard library for Karuta.
Yeah, we
I
can
think
just
it's
do this,
about time.
Mageta.
Well, but we don't have an import
Uh huh.
system. That's the
hmm
problem.
Um,
Inputs are
just
required
evaluate
to
everything on the
inform their set of
one file is already. Thank you, Nata.
Fortran vibes.
Lemos,
Uh,
let's use the proper terminology here. It's their domain. That's the proper term.
Yes,
their
that is correct.
domain. For
One interesting thing here,
outputs
like now
may.
you have naturals, but you have only one guy on the A set, right?
Yeah. Wait. A
So
set. Yes. Yes. Yes.
on the A, oh sorry, not on the A, right? On the definition of G, on the relation G, you only have one element, which is, well, one, right?
Well, the way that's written, it's basically saying that G holds for anything because it holds as
Oh
long as
yes,
net holds
that's
for
true.
one,
Can
and
you
that's
instead of
usually true.
putting, can you remove the second part, Lemus, like with the definition? Remove all of these. Yes, put one instead of A. Then now it's correct. So then the card, then it's not infinite anymore, right? It's just one element.
Okay, but you guys also mentioned this before, so um, do domain inference? Is that the term I'm looking for?
Uh, oh, you mean for the variables, right? For
Yeah,
the
no, not
outputs and
only.
the.
For example, if I try to look at the domain of G, of the inputs of the domain of G, this is not informing me, but the one is.
Well,
Oh, you're defining a relation with one value that is an integer, right?
Yeah,
Or a
but that's
natural. I
you
don't know.
only know that's an integer because of the one in here. So there are some types, well, some sets I should say, that because we don't have they're very diverse literals, we have the ability to infer them. When you have more complex data structures, I think we're gonna that's gonna be a pain in the butt. But right now it's fine.
I I don't follow because if you had like an H set with like A, B, and C, the strings between quotes and everything. So you have three definitions. Like, can you
It'll
just define
be
that for fun?
oops
Yeah, like this.
one.
A.
I don't know, three.
I mean that's kind of silly because well, I don't. I guess we don't have types at all, so that would be valid. Uh, we're making the set of JavaScript numbers, right?
Uh-huh.
Uh, so yes, but then you would need to type check, right? Because then what is plus one string with one natural, right? That doesn't make
That's already
sense.
happening in
It's not
the.
gonna hold.
Yeah, it's not gonna hold
And
with
it's not
that
gonna
patch.
hold because of the net in, right? So if you put one string, it's gonna fail on the net, but it's gonna succeed on the G, so it's already false, right?
Sure, sure, sure. No, no, no. But I'm just saying that right now, not even this will work. Actually, we don't have strings. We have spaced lit atoms, so these
That's in a
will
separate
work.
branch though, and we haven't updated that.
Yeah, but they are not strings though. They are atoms. They are just special
They are
atoms.
they are atoms. They are not strings.
Yeah, so not even this will work. But I think this would we can infer this, Maggot. So this will be a G relation, which by the way, I actually have a question for that. Are we gonna allow relations with the same names, but they have different? Um,
It's the same relation. It's just you were saying that they hold for different tuples.
wait, this is the same relation? I don't follow. Magetta just
Well,
explained a
Yeah,
actually,
relation.
G
Go on.
G is
actually
this.
the two. Yeah,
Actually,
actually
no,
no, because the
they're true,
second
right?
G has a different arity, right?
Yeah,
That's
they
what I'm
just have
talking
the same
about. Are we
name.
gonna allow
Yeah,
that?
I think we could.
Okay. So this is a relation that holds only for one. I have another question. Um, maybe it's a dumb question, but please, I'm not an expert on this. So I have my question is, how are we gonna do the six normal form guarantees on these things? Because as far as I remember, we're not talking about primary keys yet. We're only talking about relations at this point. But how are we gonna assure?
Well, you cannot define something that is not a relation, so it's already normalized.
No, no, yeah, but that's you're that's the first
That's
chapter
simple,
there.
man. It's simple.
No,
If you
no,
man,
but
if you don't have stupidity, you don't have stupidity. Done.
no, but
Simple.
that's the thing that Date said in the book in the first chapter. Oh, if you say that it's normalized, it could mean that it's first normal form. And yes, this is first normal form. But I'm
Yeah, that
talking.
doesn't mean it's further normalized. That's something else.
But that's what you know. That's what I'm talking about.
Yeah, but no, but you can't have guarantees for that. It's like for you need to look, you clown need to look at that and see if it's on sixth normal form or five or fifth.
But didn't we discuss and didn't I do an entire presentation showing that the way that the atomic was done indirectly kind of puts you in a favorable position to make it six normal form?
It doesn't guarantee
Uh,
it that though.
No, but
yes,
but I'm
it's
talking. I'm not talking about guarantees like mechanically. Like you're gonna have to do some work. You as a dummy, that's fine. But what I am talking about is having a system that propels you to do it. Such
I
as
don't
my
think we
understanding of the
can
atomic.
automatically. I don't think you can automatically do that, man.
Okay, but there is nothing that we can do on this level that we can help with that.
I can't see any
Okay.
because it's a. And here's the trick: because this like normal when you're talking about further normalization, it's not a procedure. Like people try to make those things like, oh yeah, you do this, you do that, and you follow this cookbook. But man, it's aligned to your business rules, right? So you need to interpret them and try to understand what the relations mean for the business rules. Because if the rules change, then it might not be normalized to that. That's what it means to have. That's what it actually means to have something normalized or not. If it conforms to the business rules.
I think I disagree because the definition that they talks about is not domain specific. He talks about everything being oriented by the real primary key, or
which
as
is
my
the
But
friend
business
Magenta
rule,
likes
which
to
is the
talk it,
constraint.
is
But
oriented
why
by the
does it
natural
say
key.
okay? Why does it say primary key? Because the primary key is the ontological key of what it means to have that relation in the first place.
And that is not domain specific, you see?
What do you mean?
isn't it?
Yeah, the statement that Magenta
How do
just
you,
said
first of all,
is
how do you decide what is the key if it's not domain specific?
that's a different question. Your
Is it,
first
Lemon?
your statement from before, which is the ontological key, is just how you're gonna find that. That is business related. But the fact that if you are doing everything or orbiting the ontological key, it will be normalized. That's not talking about domains, right?
You were assuming that a domain has already been pre-established and used to determine the keys.
No, I'm not. I'm talking that if you have a function with a given x,
Okay, let's be crazy. What's the key of f there that you have in your screen? Yes, what's the key of this relation of this function?
I have no idea. Depends on the domain.
Well, you already know it's naturals in that case.
No, in this case, yes, but that's the identifying what is the key, what is the ontological primary key, is different than saying, okay, if you have an x, I can do if it suffices this condition, it's fine. I don't know. Let's change this to a predicate. So this.
So can you make? I think the question is like, let's pick a function. So can you have? This is also unique, by the way. So it's just a bunch of pairs, and these are relations because they are unambiguous, right? So you can't. We're talking about sets. So unless you can find something that can have duplicates, it's already that thing is already the key of itself because that's what it means to exist, right? The problem exists of in the interbetweens of normalization between the first and sixth normal form exist if you have functional or joint dependencies with elements that are not part of the key.
Exactly. But
So
yeah,
in this case, we don't have that issue because everything is already the key.
no, no, but that's exactly what I'm talking about, Magenta. The joint dependencies and the functional dependencies and all of the criteria of normalization, their definitions are domain agnostic. If you pick them in the book and you read them, their definitions are
Okay.
not talking about any particular domain. They're talking about joint dependencies and functional dependencies that can happen in any domain. See?
Yes.
So that's what I'm
Yes,
talking
I
about,
agree.
saying that to me, uh, saying that if you are doing things respecting the normalization of the ontological key, if you are doing that, you are normalized. That to me serves to any domain. How I'm going to find the key, that's a different question that is domain specific. But the
But that's what I'm
definition
saying.
still
You
holds.
always know the key.
Oh, yes. When you have an instance of a problem of a business that you have to store data and you want to use the relational model, you will always have the key. I agree with that as well.
No, wait. I think we're talking. I don't. I lost where we are. To be fair.
No, I was talking
So
about the definition of, well, that you made a trick with me. I asked, how are we gonna make this like closer to what the Atomic did with the whole six normal form almost ish by accident? And then you said, this is already normalized. And then I said, you are right because being normalized means first normal form. And then you said, well, if you meant further normalization, that's a separate problem. And that's how we went into this rabbit hole here of this.
By the way, F has two candidate keys actually.
Sure. Uh, okay.
I think the max will always be the permutation of the set, right? Actually, not the permutation, but the factorial divided by the
Wait, what are
yeah,
you
the
talking about,
factorial
Magenta?
divided by the permutations. I know it's just thinking because you need to cut the on the set. This is only two elements, right? So you have cardinality two in that
Mm-hmm.
case for the element, right? Not of the set that I'm talking about. So in this case, it would be factorial of 2 divided by factorial of 1. So that is just factorial. Is that correct?
Hmm. What else do we need in here?
Now that gives you an upper bound in general, but it doesn't give you an upper bound that works for particular cases. In this particular
Yes.
case, that holds because, well, actually, in some particular case, you may be able to derive a lower upper bound. Is what I'm getting at, which is not
It
the case
works on
here.
this because it's totally ordered, right? And it's partially ordered as well. So it's monotonically increasing, right? And you don't have duplicates on the for each entry. You have a unique injection on. It's a bijective function,
What are
right?
you guys
By
talking
nature.
about? F?
Yeah.
Yes, F. Because if you have a bijective function on the naturals, that means that you always have the same output for the same input, vice versa, right? So you can
Yes.
invert the function.
Yes. Yes.
Uh, but you don't have ambiguity over where this element leads, unlike functions like, for example, x squared on integers, right? X
Mm-hmm.
squared on integers, if you put minus 2 or 2, it's 4,
It's
right?
4, yeah.
So
Yeah, yeah. And you're doing that to determine what? The cardinality?
the
The key
keys, right?
actually.
Oh.
Yeah, because the key of, uh, like the key, the maximum amount of elements that a key will have is all the guys, right? So minus 2 and 2, 2 and oh sorry, minus 2 and 4, 2 and 4, those are two different keys, right?
Oh, but that's a
um
composite key, right?
yeah, but in this case you can't have composite keys. You can. No, you can't. No, you can't have composite keys in that case.
In this
Sorry,
case?
you don't have candidate keys other than the primary key on the naturals of x squared, or integers, sorry.
Oh, you're talking about the square one. But in here you could, right? The composite of these two could be a candidate key.
Yes,
Uh,
because the can you write down the next line, Lemus, and
Sure.
do the x squared? Let's just compare both. I think that's a good exercise.
Mood
By
sign
the way, can you
apply.
name the function like inc? Because, well,
So this is ink and
inc,
this is a square.
yeah. And instead of net, put int and remove this g. Yeah.
Instead of
Uh,
what?
instead of instead of net on the second, put
yeah,
int.
on the inputs to square, that's an integer.
Wait, I'm confused.
The two nets on the square definition, put
Yes.
int,
Oh, here.
and
We
make
can keep the
another.
we can keep the
Make
net
make
on the second one though.
copy the square again, and put natural on those two, and put integers on the first two, just so you can compare both, right?
Wait, put integer in which ones?
Put natural there. Put natural, and roll back the second, the out on the first. Yeah, true. Yeah, then I think we have both cases. I mean, we have the permutations, but who cares? So in this case, we have inc is what's the key? Well, it is the pairs of in and out.
Mm-hmm.
But you can
Mm-hmm.
also have two candidate keys with only the output and only the input, because you don't have ambiguity. For every input, you can have the output, and for every output, you only have one input, right?
So you
So
have actually
no.
three possible keys for the ink.
What's the third?
The composite of both of them.
Oh yes, yes. You have three keys. Yeah, yeah. Okay. If you're considering the actual key as the candidate as well, yes, you have three.
Wait, you guys are both talking about ink, right?
Ink, yes.
Yeah,
So can
Yeah.
you write
I
that? I
think you
think that's a
said
good thing for us to know.
yeah, but I think you said square by accident, Magetta. I was confused.
Okay, so let's backtrack. So ink, you have three candidate keys. Can you see that?
Yes.
So in, out, they can both unique and they lead to unique values, right? And then the a pair of both of them. Those are all keys.
This is relational. This is the book of CG date in practice.
Man, this is cool. Like this is,
I told you
yep.
this day will
Okay.
come. I told you.
So okay, next one now. So on the square, yes. So on the square of only integers, if you send minus 2 and 2, you're gonna get the same value. So you don't have the partial keys, you only have the pair on this one.
Actually, in can be a partial key by itself.
I agree.
That's true because it leads always to the same value. Yes, that's correct. But on the second, then you can do the split in out and in out, right?
Yeah. Um,
So
do
this
we need
distinction
this?
matters a lot then.
No, this distinction matters a lot. That's true. But do we need this for? I think this is only important for the relational engine, right?
I think so. Yes.
This doesn't matter for us from the language perspective.
No, I don't think so. It's just for thinking.
Yeah, Prolog doesn't care about this stuff at all.
No.
Which is funny because it
So
supports it really well.
so here's a task. If I expose some um, crazy directives, so you guys can write, like for example, if I create a plus, I create a primitive net, and I expose some interface, so you guys can generate some bytecode to that thing, translating the bytecode from Karuta,
I
so
think
changing the
I think
evaluator.
that's possible. The only thing that I'm not sure, well, Marinho needs to say if it's possible or not because he's the master. I'm the pupil here. But my only thing that I remember, I think we're gonna have to change is that we don't have the what's it called, memory crawling or whatever. The mechanism to identify addresses to labels. We only do that with the outputs of a query. So these we do, but these internal ones are lost along the way. And I think now we need them. Am I right?
Yeah, I think just using the plain bytecode from Karuta directly, it runs right into that problem because we discard the names like as soon as possible.
But I think that's fixable. I think instead of
We
removing
can
them,
probably reconstruct the names dynamically, but that seems like a hassle.
yeah, I think we should just, instead of doing that, just change the previous phases. I don't remember, I think it is in the code generation that we get rid of the names. So instead of getting rid of them, we save them. And then instead of doing the crawling at the end dynamically to recover them, we
Can't we
just
just can we just make a separate bytecode, Lemos?
separate bytecode. Well, I guess we could. The problem is that that's going to require touching everybody. And that's what I was trying to avoid.
Why?
Because there's a lot of moving parts to this. We have the register allocator, we have the code generator, and the evaluator. Doing the way that I wanted first, which is to keep the same bytecode and just evaluating the entire thing, we just touch the evaluator. Everything else we keep the same. But if you think that's going to be too much of a hassle to try to um, do this double duty, I'm fine with it. I'm fine with adding more.
Can you paste what I sent here?
Yes.
Just thinking. Can you read that?
I'm not sure I know how to read this, but are you asking the database, because there has a net here, so you're asking the database for a vector or a list of all the
No, I'm asking for the out is a relation as well, right?
yes, but that's what we're gonna print. We're gonna print this variable, but this isn't a
Yes.
square predicate. So my understanding is that you want
From
100,
10 to 20.
111, 120, 139,
Yes, I
44.
want the inputs from 10 to 20, and the second I want the 10 until infinity,
Yeah, but this
and
will
on the
probably
last,
lazily hold.
yes, of course. On that case, I think we should do this. Oops, in a second.
Yeah, but we need support for lists to make this. Um, and this is actually way
Or
fancier
something
than
like
just
this.
lists. This is already using some list syntax sugar.
So you need to do some like take, something like that.
Wait, but that doesn't really look like Prolog. So
Well, you
this.
change the syntax to be whatever.
Ah, we just discussed that this is better because it keeps the Prolog sentiment.
Okay, let me change it. So this out take out two. There we go.
Okay, let me take a look on that. So you're proposing. Oops.
Uh,
I don't know why I didn't paste the correct thing. There we go. So is this better?
I think so.
So let's take a look. So this is missing a square. Oh no, it is not. Wait, isn't it this? Am I crazy?
No, no.
You do a
What?
query with
Man,
multiple things
square
like
is.
this?
Yeah, I don't see the problem.
No, no, no. I'm asking a Prolog question. Is this how that works?
Oh yes, yes.
Okay. I didn't know that.
What I typed below is actually wrong
Yeah,
because you're
no.
assuming a predicate, right? It's not the out, which is the actual
Yeah, yeah,
relation.
yeah, yeah, exactly. This was my original idea that is not doesn't feel like Prolog. I didn't know you could do this type of stuff on queries.
Well, that's conjunction, right? We don't support that yet.
Wait,
Oh, you guys don't
wait,
support
wait.
that on the interrogation?
No, we don't have query conjunctions, but that's not hard to implement. We have already the boilerplate. It's just a matter of stitching together. Uh, we already have a place which with a to do in there somewhere. So what is this
So this
doing?
would be so this would calculate 10 to the
Isn't it
infinity.
this?
No, I don't think so. It's only one statement, right?
Oh, I see. Okay.
So
I mean,
you would project a relation out with all the elements squared from 10 and beyond and take only two of them.
Marinho?
So that makes it not lazy, right?
mm, yeah, this seems alright. We would need some way to interface the output of the database with ordinary data structures, but we were going to need that anyways.
Okay, cool. What is this?
This is a pace, like a step.
Ah, okay, so this is the step. Okay,
I
so
don't know if the syntax is good though.
we usually do, well, I've seen being done like this.
Oh, that's cursed, man.
But that's how that usually
Because
goes.
cursed and then dots. That's much better. Because I don't like the commas because they're already the end, right?
Ah, okay, the symbol.
There are two things already. They are arguments, separators, and the end, right? I wanted it specifically to be slicing. So, for example, the list, like for example, on the 20, what if we put a special syntax for like a parentheses? Yeah, line
Wait,
21
where the parentheses here?
on the end of 20.
Here.
Instead of this squared bracket, put a parentheses.
Here?
Yes, that's an open, right? So it ends on 19. There's that option too.
Wait, I don't follow. What is this changing?
It starts inclusive on 10 and
Ah,
it ends.
inclusive and okay, I see what you're talking about. Well, we have that option. We haven't used parentheses yet.
Thank you, Nathan.
Okay, so let's now do the. Okay, we already. This was productive. We already divided. We have a plan. We have a plan. But now let's put action items because I think I'm kind of missing that. So let's divide relational engine work from language work. So from the language perspective, let's put a to do. So language, Karuta language to do list. So first, we need to introduce special.
Why don't you put this on the README, man?
Yeah, I will move it to there. Introduce special syntax for database support using using at.
By the way, I don't think we actually need to change anything in the parser or most of the pipeline. We just need to forbid um, until we actually implement integration in the database, forbid predicates from being defined that start with the at symbol.
No, but
Basically, we reserve all.
we're gonna introduce this anyway. So forbidding that will not be like it's not gonna stay prohibited for long. Introduce bytecode dedicated for database interaction. Um, and I guess from the language, oh, we need lists, list literals. I'm gonna also put here range syntax sugar with for query conjunction. And then finally, serialization uh, for relational engine protocol. Okay, so this I think, am I missing anything for the language?
I think that's it.
Okay,
Uh, no, that's fine. You
relational
already included 5.
relational engine to do list. So I guess the first thing is to introduce relational built-ins. Net int plus multiply. I think that's enough for now. Second, um, actually I have a question. Oh, this. Okay, okay. I see.
Magetta, out of curiosity, how many database engines actually use relational constructs to do numeric operations?
0.
We are making history, boys. Introduce support
I
for
think
query.
I don't know. I don't put my hand on fire. It might be that Project M36 does. I doubt, though. I have my doubts because uh, I don't think it's very ergonomic for you to handle them as sets as well most of the time because of the structure that they define the language atop of. I I wouldn't be that surprised if they did, to be
I
honest,
have a
but I
question.
don't think so.
Will the relational engine do the checks for like? Man, I think the engine should not do that because here's the problem. Let's say that I call square, for example. Well, this is gonna fail because you're passing lists to it, and if you define these like this, we kind of would have to do like multi-versions. How do we int there? Something like that because otherwise this will fail. So I have a question. Let's say that I'm doing
Wait,
this in my program and I am trying to interact with the square table, square relation,
okay.
and I made a typo and I put a string in there. I didn't put either the list int or the int. Where should I'm gonna get notified that I made a mistake?
Well, the
So
query should
wait,
fail in this case, right?
yeah, it will explode, right?
But at which moment? Because there are a couple of moments in this puzzle. We have the moment that we are going through the runtime of Karuta, and we have the moment where the information is going through the runtime of the engine. The way that I think
I
we were currently
if we're
thinking, the
doing it
engine would explode. But that sucks because this
if
takes time. There's an
if
a
we're doing
connection
this
here.
properly, if you're doing this properly, I think it should fail on compile time, right? Um,
Okay, so there is a 6 here.
but
Um, but for it to fail at compile time would imply that the compiler knows the types of the relations of the
yes,
database. Uh,
yes. So you will need a schema defined in your code, essentially, in access through Karuta, which I
But
think
we
you
are doing
could
that,
do.
no? Here.
Oh, this is not a schema. This is annotations, right, of where the things come from.
No, 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 no. But okay, let me backtrack because I think now I miscommunicated. When I was talking about, okay, we have to have a way to do select and create table. Create table. To me, this is the create table in our world.
Yes.
This means that we do have the information available here.
Well, yes, you have annotated the in-out values, yes.
So we have, to the extent of compile time, we have, well, in this case, we have a problem because
Oh,
outputs may not
actually,
inform.
what you have there is that you have int enforcing a constraint over the opaque variables, opaque type variables, enforcing that in must be an integer and out must be an integer. And then every other function that uses them must support that interface. That's like Hindley-Milner, right?
Yeah, no, exactly. But what Marinho said, which is that, oh, now the compiler needs to have some information about the schema of the things that the engine knows. My argument is that this is already the case in here.
you are assuming that only Karuta and only this particular program will talk to the database and define tables then.
No, 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 yeah,
Yes,
there is
that's the
that
thing.
problem. What if I did this in another, in
On
another,
another process. Yeah.
exactly, and then I need to get informed? I think we can also get around that, but that's gonna take a little bit of, that's gonna be more expensive because my idea,
Well, we
which is very
can we
naive,
can make a
a
schema.
shake, a shake hand between the relational engine and us, so we can get the schema information for the relations that matter for us.
Yes, what I was going to suggest is for the program, like the program can do the this handshake, right? And the database, the engine provides an endpoint for sending the schema,
Um, okay,
and
here's
then
a
you just
problem. Here's a problem
Mhm.
though. If we do that, let's assume that works, okay? Let's assume we're walking down rainbows and touching clouds and all that good stuff.
I
That
see a problem
means
of concurrency
the
with them though.
compiler is no longer deterministic.
But this is
Yes,
doing a
very
database
much.
connection. This is already like fucked beyond belief.
No, 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 no. I'm talking about the compiler by itself. It's no longer deterministic because the result of compilation depends on the contents of the database.
Yes, but if you're using this directive, I think that's fair.
Well, it's not the content per se; it's the schema definitions that are in it, which is content. Don't get me wrong, but it is not the tuples, right? Which is what I would say as the actual content. So you're not looking at the tuples; you're looking only at the definitions of the. So it's less
Okay,
worse than that.
what happens if you add a tuple between compilation attempts?
Yes, then you have a difference. That's what I was talking about concurrency, right? Because if you're compiling something and then someone else makes a change on the database, one thing to solve this would be the database to have branching and then you have a hash both ways. So you have to do the handshake with a hash and then you're sure that you're
Aren't
having
we just doing
the
continue work at this point?
yes, a bit.
Fuck. Okay. Okay. Let's not go that far beyond imagination because that's introducing too many problems at
I'm
once.
pretty sure when we get there we can solve somehow.
Uh, okay. So,
Even if it's
uh,
catastrophically bad.
but I think okay. Nathan said some stuff. Query from the DB at compile time. Yeah, I was kind of thinking of doing some meta programming to talk to the DB before anything. Uh, like the meta program.
Congratulations, your compiler is no longer a pure function.
Well, but again, we
Based.
are introducing a database connection. This is not. dreamland anymore.
Man,
I'm
what
not
you,
talking
the
about the
way to
runtime. I'm talking about the compiler. Your compiler
man,
is
man,
no
man, man,
longer
wait,
a
wait, wait,
pure function, Lemos.
folks. This can be solved very easily. Make the database output Karuta code that contains the schema. Done. And then you just store the Karuta code. It might still break at runtime
No, 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 no.
if
But
the database is using another version,
we're gonna
but
do some. We could do something like that, Magetta. The problem is what Marinho is complaining is that right now our compiler is a pure function in the sense of you
yes,
provide
it would
some
still
text.
be.
No, it would not, because let's say that in the
Why?
first step, because okay, we're gonna introduce another phase even before pre-processing and parsing, which is the one that talks to a database.
Why would you do that if you already know what things are, man?
Because
That's
in
my
the
point.
beginning, you may have done some schemas for me, and I need to connect to you to get the Karuta code with the type annotations.
That's a break at runtime, not a compile time.
Wait, so you're suggesting that you're gonna exchange and do the handshake at runtime?
No, man, no. Forget handshake. I'm talking. Do this. Database gives you a schema. So you store the schema as a file in Karuta, and then you import that file, and then you use that to type the functions. It
At
has all
which
the
moment
directives.
am I getting the file? That's my question.
Well, you as a programmer is in charge of connecting to the database, making a query, getting the current schema, and then you use that schema as a file in your Git.
But that's not gonna be responsibility of the compiler. The programmer will do that.
Yes, that's how it works today on any vendor that I know that has schemas. That is.
What do you think, Marinho? I think Margeta's idea is actually the best right now.
Like, man, what I'm saying is, like, I think if we find a problem with these, like, we're gonna go on a rabbit hole that no one does. Like, we're
But
trying to
we are
solve a
doing things
problem
that
that
nobody does already.
eh,
What are you talking about?
Virgo Lang of you. Code generation is a really good idea. It doesn't need to introduce some more specific metaprogramming at compile time.
Yeah, no, but Mageta's idea, Nathan, is that we instead of we doing this mechanically, like talking to the database before doing our like before compiling our own program, we talk to somebody else and say, "Hey, buddy, could you give me the schema, please?" And then the buddy gives you the schema, and then you run the compiler.
I'll give one example. So, like, F sharp has type providers, right?
Mhm.
So you can put a query string to Postgres on the type providers input for your database, right? And they will like infer all the types and type check if it has access to a Docker container running your database version, right? And all of
Mhm.
that. Uh, but you also have the option to embed a string that is pinned in your code, uh, defining the schema as you would as you would expect. That's also an option, right? What I'm suggesting is for you to ping the schema as you think it is. It might not be correct. For example, you might you might want to deploy the code and then it runs and breaks because someone pushed a change. But well, that's version management. Uh, the other option is a bit more hellish. I think we could still do something in that regard, and then you guys give your thoughts. Which is to uh, do the handshake and etc. But then you have the problem that your compilation from one process to the other is not a pure function, as Marinho said. You need to make a call to the database to
Call
get
to
the
the
latest
database to
schema.
get the latest schema. I think,
You can ping that as a
I
hash,
think, you
etc.
can
But
do that
well,
as a hash, etc. But man, the return
oh,
is
I'm
crazy
getting
from Nathan.
feedback from.
Yeah, it's from Nathan. Go, Nathan. Say something.
I was trying to fix my microphone. I hope it's fine now.
Mhm.
Uh, yeah, as Magetta said, stuff already exists, and I think they might be good enough. As in, okay, you maybe have the option to talk live with the database, but you can just export something from the database and then use it at compile time as, I don't know, something
I
like that.
think I think we
But
could do a couple of actually after Magetta explained a little more the idea. I think I have a couple of strategies that we could consider. For example, if you provide a file with the types, with the types, use that. If not, um, you can pass a flag to skip the check. If the flag is not provided, you impure the compiler to ask the relational engine. We could have a priority system that works like this.
Uh, yeah, I would hope for you not to do some kind of priority slash defaults. You just call the thing you want and that's it, more explicit, right?
No, but
And
that's
of
that's exactly
course,
what we're trying to avoid because Marinho wants to keep the compiler as a pure function.
so I'm not sure what's the problem.
No, the problem is that Marinho wants to keep the compiler as a pure function as much as possible. If we
But
always talk to the
It's
relational
fair.
engine to talk
how
up to
does that
Not
talk,
conflict with
banalizing that.
what
It
I
is
said?
fair.
yeah. Nathan, repeat the question, please.
How does that conflict with what I said?
No, you said that we should always ask, right?
No, no. What I say is instead of you calling some kind of function and based on what should pass or doesn't pass, it uses like one and then fall back to the other. You should just call explicit ones to either you want to do that or the other, not a function that does implicitly one or the other,
Oh, you
right?
don't want default behavior.
Yeah, you just choose what you want to do, right? And because, well, you will need specific stuff for them anyway.
What do you think, Mageta?
Uh,
I didn't follow. Can
The
you?
question is, Nathan, like this thing that I proposed. This would do like a chain of checks. So, for example, let's say that you do Karuta, eh, Karuta. I don't know how to type today. My program, and then I say, I don't say anything. And let's say that this program has database shit.
Hmm.
So, according to my strategy, it will check. Are you providing me a file with the type of notations for the things that you're
Oh,
doing in the
and instead of
database?
thinking of a file, like think of them as normal functions, right? So are you defining them somewhere in your source code?
Yeah. Again, I prefer to talk. I don't like talking about functions in this context because what we are looking for is this, right? That's what we are looking for.
Yes, is that relation int defined
Exactly.
somewhere, and then you would
No, no,
have
no,
something
not
like
the
a header.
int, the square.
Oh, int square. Okay, if you want to ignore the rest and not check them, that's fine. But
No, no. What I'm
when
saying is, let's say that I am using square in my program, but square is not defined in here. It's already been created. It's already on the disk and has data on it. And I'm trying to do, I don't know, this for example, assuming everything syntactically makes sense. What will happen? How will the compiler tell me that this can be here? What if I put a string in here? How the compiler will tell me it's wrong? It needs to know that in and out they have specific types with them, so I can compare with this. The question is, how do we get them? You answer that. You ask for it, and then I don't know. You said Karuta code. Okay, so we're gonna have a file with this in there, right?
yes, that's one option.
Exactly. So
Literally, what I'm saying is literally a C header. Like
yes,
this
yes,
exists.
yes,
Assume
yes,
that
yes,
this
yes.
exists.
My proposal, which I'm going to contrast with what Nathan wants, is I have a system that will have some default behavior. So, for example, I'm not providing you a file, right? I'm not providing you with the files with a file with the headers. And I'm also not saying to you to like don't check. I'm not passing you a flag to the compiler saying
Lemos,
ignore the types. Then I would talk to the relational engine in my suggestion. What Nathan is suggesting is for us to never have default behavior, and we always explicitly tell the compiler,
uh,
database, don't check, or I don't know, network, or
There is actually a slightly different option.
go for it.
If you don't pass a flag to skip the check and you don't have a file with the types, then if you have database stuff, you just fail compilation because you don't have enough information to proceed. And then if you want to talk to the database at compile time, you have to pass a flag because that's opting into impure behavior.
What do you think, Nathan?
That's the thing. I maybe those things are not even relevant because maybe they are relevant in the case you are, I don't know, either passing some file at compile time or connecting with the LiveDB. But if you do the code generation, as Mageta said, that's just code, that's just type. You're just compiling a normal program. But one of those files was generated by the database, right? So there is no special shit.
No, you are missing the plot, Nathan, which is the same thing that I was asking
Folks, I'll go
Mageta.
have dinner. Be right
Oh,
back.
okay. Here's the plot, Nathan. The question is when we're gonna get this file, regardless if it's gonna be generated or not. That is the question we're trying to solve. Because
It doesn't matter. When
you
you
know it
compile the
does.
program, hmm,
It does. Because the way like if I get the file first, I don't have to change anything. It's just normal. I just import the file and I'm done. Right?
sure.
Doesn't change anything. The other ones, the other alternatives, which I guess we're not gonna we let's ignore this one for now. The one talking about the relational engine at compile time, that's what we are trying to avoid, right? Are you
The thing
following?
is, yeah, the thing is, Mageta was talking about code generation. Of course, you have the file before you try to compile it.
No, you are that is a premise in your system. Okay, in that case, doesn't matter. You all of this doesn't matter to you. What we are talking about is like, what if you don't have the header? Manin, could you
What if you just
repeat you
try?
go
Yeah,
ahead.
like if you try to do a database query in the middle of your program, and you don't have that explicitly defined, as in you don't have the file with the types that was generated,
Mm-hmm.
and you didn't pass a flag to skip the check or whatever. Then what can you do? There are basically two options. You can connect to the database and say, "Hey, tell me if this relation exists and what are the types, right?" And then I can
Exactly.
proceed.
Exactly.
Or you can just say, "Okay, you didn't
Fail.
tell me what this thing is, and
Fuck you.
we just fail." Yeah, you have to tell me what it is.
Okay, so you are essentially doing proposing what I propose, but um, if another flag is provided, if nothing above, fuck you.
Yeah.
I will I will fail. Okay. Okay, I think this is fair enough. What Nathan is describing is essentially that we always gonna have the header file anyway. So that's good. Okay, let's go back to the relational engine to do. So we need to introduce relational built-ins, such as net, well, which is essentially the set stuff. We need to introduce support for creating multiple values. So this needs to be supported on the engine level because we're gonna dispatch somehow. I don't know how yet. We're gonna dispatch this. Marinho, I want to know your opinion on this thing. Like, how are we gonna handle this thing that Mageta wants?
That's basically dispatching based on the type of the argument, right?
So yeah, but what is gonna be the solution that you're gonna use in terms of the schema? Because this is introducing some stuff that is not um, described by the relation description. For example, this. This is not talking about lists at all.
Right.
But Mageta wants to be able to do this type of stuff. So how are we gonna do that?
uh, that's a good question.
Okay, I have no idea how we're gonna do that.
I mean, that's a kind of polymorphism, right?
Yeah, well, it is. Yeah, actually, no, it's not kinda. It is polymorphism. But it could also not be. Like we could have some sort of way to know how to behave when there are lists of things that are types that we support, you know?
Oh, I mean like APL.
I don't know APL enough to agree with that, but
Like if you have a
Maybe.
numeric function on APL, it just automatically works for arrays of any dimension actually.
No, but no, yes, but that's because that's, as far as I can tell, that's real polymorphism right there. What I am kind of suggesting is a trick that the compilers is smart enough to know that if you have a list of things that are the things are the type that type checks, it knows automatically that that it should zip them or whatever.
It's not a zip, it's actually a map.
Yeah, a map. So I was talking zip. Think about
I
another
mean,
thing.
I mean, it's not really that different from APL. You just say, okay, does this match the input type that I expect? If it does, we just call the relation. If it doesn't, we try to map the relation over it.
Exactly. But that would be like dedicated behavior for lists that will not be part of a more elaborate
No, 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 no,
polymorph
not
system.
not for lists, for functors theoretically.
No, but this is a list, right?
Well, yes.
Yeah, that's what I'm talking about. So like when interacting with lists, we have a special if that does very dedicated behavior.
No, no, it's not really when well, I guess it would be when interacting with lists. Basically, if the relation does not expect to receive a list, it expects something else,
Something else.
but you give it a list of that something else, then we can map the relation over the list, assuming that the relation is actually a function, right?
And that will be transparent.
Yeah,
So I think that's doable because that doesn't mandate us to go full-blown polymorphic. Although that
yeah,
would be kind of cool.
yeah, we can probably handle that.
Okay. Um, okay. What else the relational engine is going to be missing? Define a protocol. Runtime. Okay. Okay. Now you and me, Marin, let's settle the priorities for our these to-dos because I didn't do them in order. Okay. So which one? I think this should be definitely be the last one.
I agree.
Okay, from 1 to 5, what do you think we should do first? I think we should do these first.
I also agree.
Then I think we should do these next.
I also agree.
And then this, and then this, and then this. What
Yeah,
do you
I think
think?
that makes sense.
Okay. About the relational engine, I think this is already in order. Maybe you can swap 2 and 3 actually. Actually, let's do that because this means that we can test it earlier. What do you say?
Yeah, basic features before fancy features.
Okay, let's now actually before that. Okay. Let's now put this in the README. I'm gonna keep this file as it is, right? Because this file has like the ideas that we discussed for how the database mode it's coming to life, man. It's coming to fruition. You see, we are finally
Yes.
getting to the point where we envision. Uh, oh, we also we also need error messaging at some point. Terrible.
I'll be right back.
Fucking terrible. I think that's enough. Um, and now we can also okay. And then we're gonna do okay. Now we are kind of talking. Special syntax for database support, and I should change this to that. Dedicated I think that's how that works. Okay. So if I go back to factorial, yeah, there's a bunch of crap that doesn't matter at all. So let me kill the changes. Yes.
I
Magenta, you're
think
back?
I'll
I'm
do the. Yes, I think I'll do the
I'm
Okay.
back.
I
interface
added
already.
some to-dos to the README.
Let me see.
Uh, so more to-dos in the language level than the database level, but these are the current to-dos that we have for in order that we thought makes more sense to be done first. Uh, and we have, yeah, those are the only three to-dos for the relational engine portion. And we have a bunch of stuff. So we already have this in a separate branch. Then we're going to work on list literals, query conjunction. Not today. Introduce comments to the parser because why the fuck not? And then this portion is kind of the database things that we discussed today. And I'm keeping the file, this file, with the rules. So what do you think?
Mix domain for this. Yep, that looks okay.
There is a question that I think we can still discuss. What about
Not test.
formatter?
Yeah.
Yeah, I have absolutely no fucking idea. We don't have
It would
even
be
error
nice.
messages. You're talking about formatter. Magenta, I have a question. I'm kind of bothered by, well, not bothered. I want to ask you and Marinho and Nathan, how are we gonna interact the PL code with the database code? Because we talked so far about doing queries. What if I want to use the values out of those queries in a program?
I mean, you can just put a query in the middle of a program. Problem.
Oh, so can I just do?
Not like that though, like a normal predicate call.
Wait, I didn't follow the question. Like,
Can I do something like this, Marinho? Um, the question. Let me repeat the question. Uh, Again, the question is: we just discussed how we're gonna join
oh, how you
database
take
mode.
the output?
Yeah. How do I mix them together? Because that's what make programs
Uh,
useful, right?
yeah,
I
well, I
mean,
suppose.
I mean, we can just call the database from Karuta, right? If we have a protocol, right?
I don't know. Main. right? So let's say that I have an input,
Um,
and then I
I
want to
think you
say
can
inc,
do a variable assignment, maybe.
inc.
So like what Prolog does, like x is blah blah, and then x is the relation that is the output of blah blah blah. You see?
Okay, how do I make this? That's kind of my question.
I mean, you just replace the question mark with a dot. Or rather, get rid of the question mark because that's not a query,
Oh
that's
yes,
part of the body of a
yeah,
predicate.
that's the body of the
But I
predicate.
am
The
querying the
actual function is
database. I'm asking the
yeah.
database,
That's denoted by the at sign, not by the
which
question
by the
mark.
way, that's denoted by what?
The at sign, right? That's already
In
a
front of
question
inc,
to the
you're
database.
basically saying, yeah, basically saying I'm calling this database predicate called inc with this input, with these two variables as arguments.
Yeah, but how do I like this is also doing a query, but this is not in question mark. So this is also a
Well,
select.
ignoring that you would have to instantiate the database, blah blah blah.
Yeah, yeah,
The
yeah.
question mark is basically the entry point for for this file, right?
Yes. And multiple questions marks are just conjunction, right?
Yeah, it's the same as putting commas in between them and having just a single question mark. The point
Okay.
is, you
Mm-hmm.
kind of already have um, the question mark as the entry point, but then what you do in the predicate that you call there is up to you, right? If the predicate wants to call the database, it can just call the database. Why not?
Okay, so this is also a select.
Well, you can only do. Give me a moment.
The real question is how do we make it play nice with backtracking?
That's an awesome question, isn't it? I think the way that this should needs to work, Marinho, is the following. We save like when we encounter this in the runtime, we need to stop everything and ask the relational engine, what is the value of this thing?
And
Well,
we
if
need
this is
to make
required, right, for continuing the like if you have commas and
yeah,
whatever.
and we need to do that, and we also need to have some way at the protocol level to let to allow us to ask for multiple results one at a time, right?
What do you
Because in
mean?
this case, because like if we have a predicate call in such a way that it can have multiple answers, like for example, in this case, you call inc input output. Assuming the input and the output are both free variables, then there are potentially infinitely many answers that the inc can return, right?
Ah, now I understand what you're saying.
Yeah, we need to make that integrate nicely with backtracking in the prologue side so that it does what you expect it to do.
Man, that sounds tough. I hope you have the ideas there, Marin. Um, okay, but that's essentially how we're gonna do it, right? We're gonna essentially,
Okay.
when we see the at, we're gonna immediately stop everything, talk to the guy. The guy gives us the potential many answers for output, and then somehow we have to hook that with the unification system to try to see if this holds, right?
Yeah, right.
Again, are you following what we're talking about here?
Yes, I'm following. I'll start simpler, and I'll do. I think I can do that today. Even the simple interface to allow you to send the request to get
Sure, sure,
uh,
sure.
a relation with
Um,
its data.
I have there's a problem. Oh, okay. This is we talked about this problem before, but now I think maybe we have different ideas. This may be a petabyte of potential answers. How in the
We
fuck
need
are
to
we gonna do that?
we need to
Oh,
string them incrementally. Yeah.
Are we gonna
um,
paginate this
ev-
shit?
everything on the database it gives you a uh, iterator.
Oh, so it will be paginated. Awesome.
Unless it's a single value, then it's, well, yeah, I guess to maintain consistency could be a single iterator. But yes, everything is already paginated by default because you already have infinites.
How in the fuck are we gonna handle the backtracking?
Take what backtracking? Oh, you're thinking of.
Like,
Because Prolog can do backtracking with the answer that it gets from the database, right?
man,
I can send a. Okay, if it helps, I can send a.
Basically, we need some way to say, okay, database, give me one answer, only one, but remember that I may ask for more.
yeah,
I can do that.
yeah. Man, but that's gonna be so in fucking like it's gonna be painful but in a fun way because I have no idea how we're gonna mash those two things together. We have to ah okay. Okay,
If you do
that's
this,
great.
you can publish that. By the way, encouraging. I hope.
uh okay. No, no, this was very productive. We discussed a very like very good direction. Let me do a commit in a separate branch of this thing. I'm actually gonna keep this. How do we plan on doing the imports? I just pulled this out of my ass.
Folks,
We need a
what
module
about
system, don't we?
Yeah. Go, Nathan.
folks? What about network failure? How
You're
is that
fucked.
handled
You're
on the?
fucked.
There is just no idea of failure in the language, right?
Well, failure is backtracking.
I mean,
Huh?
But we
if
shouldn't
it.
backtrack on network failure because that's impure.
Yeah,
I,
exactly.
well,
We should
uh,
just blow up in that case actually.
Yes, I think
yeah,
that's
if you are
probably best.
requesting more from the network and it failed, and you cannot do anything else if you don't get more input, then yes, we should just collapse the entire thing. Talking about the module system, Marinho, how do you imagine that working in a logic language?
Yeah, I can
Uh,
imagine a very good way to do it.
No, but I want to see if his Marinho means namespacing or real ML modules.
Oh, that would be base.
Because I have no
I
idea how to
mean,
mesh those two.
we could try to go the same way that Oz goes, but that kind of assumes that the functors are labeled and not positional, which is not the case in Prolog.
You know what's interesting? If views are modules and views are also relations,
Wait, views in the SQL sense?
yes, I mean not in the SQL sense because in the SQL sense they are retarded, but
I guess we
uh,
could fake labeled tuples by using a
concat files.
relation. That is
Thank
true.
you, Nathan. Thank you. Nathan gave a solution. Concat files.
Marinho, repeat please.
Yeah, I guess we could fake labeled tuples by using a predicate, I suppose. But we don't have higher. The problem is that we don't actually have higher order predicates. That's kind of the trouble there.
I think that for starters, we could just use a namespacing system. So when I import factorial here, um, I actually can do this.
You have to give it a prefix, yeah.
And then that's how that, because this is I think enough for us to start having like standard library. Like for example, the function that you did last time, Marin, that when we were talking about the minus, we can have a math here, right? The implementation that you provided last time, which was
Yeah,
already
we
in
could.
Karuta terms.
Yeah, we could.
So cool. Okay, I'm pretty excited. Uh, in prologue mode, it doesn't look as bad actually. It's crazy to think that this simple thing is already better than C. It's not so hard, huh? It is not so hard. Let me do a commit. Karuta. So I haven't saved this file apparently. Let's do a
Today was very
stash.
productive. Today was very productive, Lemos.
Yeah, no, we had a design meeting that we actually talked about like this is the thing about doing things with patience. We spent the time, we have a language, it works. Now we can have the luxury of going outside of this of like, okay, there's a book about it. We're gonna write our own book now. What's gonna be in there? Okay, so let me pull from master. Let me check out a separate branch. So integration stash pop update readme and add example push. Okay, now it's just a matter of opening the PR and we're good to go. So either one of you, please draft of database next steps for Karuta. Please approve this PR here. There we go. Who is talking to me? Damn! Nathan's using NixOS.
Wait, Nathan is using what?
NixOS.
Nathan is using
Yeah,
NixOS?
haven't you checked the chat?
No,
The
I
secret
haven't.
chat?
Oh, give me a sec, give me a sec.
Okay, are you the product owner of Karuta? Well, sort of. Mageta has the ambition that we need, uh, but Marinho and I were trying to make Mageta's dream happen. It's kind of like that, how that works. He's the dreamer, and we are the doers. So that's how that works.
What do you mean? What is geeks but with JS, Nathan? That sounds cursed.
But that's what he wants. Mageta is the CEO. Well, in a way,
CO, what the heck?
well, because you're the one that dreams, and we're the one that make your dream happen. Eh?
Aren't you guys in a nightmare?
No, because this is a good dream. This particular one. Uh, okay, so what are we going to be doing next time? So, Marin, I think we can merge the. I think we should merge the integer literals. So the PR is already open there. I think Mageta should be the one reviewing that, but I don't know if he's willing to.
I can try.
Uh, because I have commits in there, Marinho has commits in there, integer literals. But can you also take a look, Marinho, in the PR? Because there is some. It's actually not that much code, so I think it's a quick look would be enough.
Sure.
And then next time, what are we gonna be doing next time? We're gonna be doing. Oh, I need to do a. I need to pull to the other branch of literals. So let me do. Let me quickly do that. Check out literals. Log. Git pull.
Anyway, I'll try to work on the protocol, like at least have something, and on the list, and try to plug and make a thing that you guys can actually use. Folks, I need to go because I have a class in 10 minutes.
Have a great class. Is it piano?
Uh, No, grammar.
Oh, awesome. Have a great
It's
time,
like an
Magenta. Thank you
old.
for being here today.
Are you? Is your class underground, Mageta?
I wish, man. I wish. I guess it is on the catacombs. Yes, I guess you can describe it that way.
Oh, so you were studying with an underground grammarian then?
Underground grammarians. Yes, they're the best.
Okay, so now, Marin,
Very
what we're
nice.
gonna be doing next time? I think we should do list
All right.
literals.
See you guys.
See you, Magit.
See you, Mageta.
I think we should be doing list literals and comments next time. And if we have the luxury of more time, we can do the query conjunction because I think that's not that hard actually. What do you say?
Yeah. Yeah, we can definitely do the list literals. Comments. Yeah, that's pretty easy. Query conjunction. Yeah, if we have time, we can do it. It's
Probably
probably not
not.
hard, but it's also not trivial. It's
Yeah, I would say that I think if we are very, very productive on Friday, I think we can do list literals and comments fine. Actually, I'm not that sure about the list literals because they involve changing many places because this requires the book, right? I think this is going to be one of the last portions of the book that we are still missing. Um, so maybe the list is going to take So I think we should actually do comments
I mean,
first on Friday.
I mean, technically, if we want to be kind of lazy, we don't need the book to do list literals. We can just desugar them into functors that have a
That's lazy as fuck.
particular. I mean, it would work. It would not be as nice, but it would work.
Let's try to do the book way first. Let's not try to hack our way through. Especially because all of this is a hack. So let's do list literals, trying to do them properly, and comments. If we have time on Friday, we try to do the query. I don't think we're gonna have time on Friday to do the query.
Um, Actually, there's one other thing we should try to do also before going into database stuff, and that is libraries.
Oh, okay. So draft import library system. Let's settle on a solution. I want the namespacing solution for now.
Let's go with that. We can even just use the traditional syntax that Prolog uses for like directives, so we don't have to bolt C syntax on top of Karuta. That would be nasty.
What do you mean bold C syntax? You mean the hashtag?
Yeah, the hash includes. That's kind of not nice.
Really? I kind of like it, but what do you prefer?
Well, the traditional way, and actually Erlang borrows, completely copies this, is to do something like this, right? Where you do a clause, but you don't have nothing on the left hand. You don't have anything on the left hand side, and you just include, and then you put the module name in it, kind of like this, right?
Ugly as fuck, but okay. Oops.
I guess to be more consistent, we should name it import, right?
Like this?
Yeah.
Ugly but consistent is indeed better. Why is it not just this?
Because that looks like a fact.
It is a fact that I'm importing factorial.
No, 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 no. That's looking like you are defining a predicate called import, which is a fact that holds factorial.
Man, this is ugly as fuck, but I cannot deny the. Like, if Prolog does it, who am I? Okay, so namespacing after the comments. And then we do the database stuff. I think there's a problem. I think there's a possibility that Magetta will already have something useful before we finish these four.
We can probably skip the query conjunction if it comes to that. Namespacing shouldn't be too difficult.
Okay. Do I want to save it? Yes. namespace and private stuff. Okay, let's actually discuss about that. How are we gonna do the private? So for example, I don't want to export to the outside world factorial 3. I don't. How can I do that? Marinho?
Like this.
We are already using arity, Nathan. That's already like a given.
Like this, Lemos.
Ah, so you have an export thingy. I see. I see. Okay, so that's gonna be part of our thing. Cool. Awesome. Let's do a commit. Okay, Marinho, could you check stage all changes? Yes. What the fuck? I don't want any of that stuff. Do I have? Oh, I do have. Okay, so C update readme. Actually, add namespacing item to readme. That's crazy. Okay. Okay, so now can you take a look on the PR, please?
I'm looking at it.
I will finish the recording now.